Now we're in business. They're like, oh crud, Hardy's recording today. It's true. It's true because I forgot to last hour. So, on page 3, oh, everybody's favorite. Absolutely not. Everybody's favorite word problems there. Friday word problems. Nice combo, Hardy. So, as we're looking at this, okay, again, over on page 3, write an equation or an inequality and solve. We're looking at a combo of the last 2 days. We're going to take our equations, our inequalities, but now we're going to take the word problems that we did during the first quiz and we're going to do this mishmash of them. So, when we get rolling here, and by the way, happy September, we're going to have to jump into the middle. Lock in! For the people at home, too. Sorry, I just screamed in your ear. When you're looking through these, it's more than just grabbing a bunch of numbers in here and throwing them down and go, well, I got some numbers. What do I do? What it's going to be is taking some key words that we find and using them to our advantage. So, how do I find these key words? Well, let's see what it says. It's currently 52 degrees outside and increasing at a rate of 2 degrees per hour. Okay, we'll be back to that. The weatherman says the high temperature for the day is 76. Write an equation to represent how many hours it takes to reach the high temperature. Okay, first thing, let's see what we're looking for. How many hours does it take to reach the high temperature? How many hours? Okay. That's going to be my variable. You use any variable you want. I just use X because I'm kind of boring sometimes. So, it is currently 52 degrees outside. Now, that didn't say anything special, so I'm just going to kind of write down 52, see where this goes. And is, oh, first key word. Increasing. If we see math words, you're like, well, what if I don't recognize the math words? We've got all those math words on the front page of your note packet. So increasing right there says plus. So, okay, so 52 plus a rate of 2 degrees. Okay, 2 per hour. How many hours? Per hour. When you see the words, I'm going to add a little something extra here. For those of you in here, you can see it on the sideboard. If you see the word per or the word each, and this is in your note packet too, it's time to put a variable in. Because for every hour, it's going to go more and more and more, depending on how many hours it's been. So, my 2 gets an X. And I keep reading. The weatherman says the high temperature for the day, here comes our next word, is equals. Is 76. Write an equation to represent how many hours it takes to reach the high temperature. Once I know what X is, I'm going to know how many hours it's going to be into the day before we see the high temperature. So, let me move this for a moment. Let me come back here. This looks eerily similar to what we've been doing the last couple of days. I need to take my variable term, and whatever is not in the box, whatever I'm not looking for, needs to go bye-bye. So, how do I undo a plus 52?
Minus 52.
That couldn't say it any better. Even loud enough the people at home would be able to see that. I like it. Okay, I ran out of room though. I wrote too big, so here we come. 2x equals, and again, use your calculator if you're not sure. So now we're almost there. But I want x. I don't quite have x yet. I'm multiplying x by 2. How do we undo it? We divide by 2. it's going to take 12 hours for the temperature to get up where it needs to be. Now, I will always have somebody ask, and I'm glad that they do, hey, Hardy, now to be perfectly honest, I could just look at that and in my head say, okay, 52, 54, 56, 58, 60, count it off and write 12. Can I just write 12 that way? No. Why not? I can do it in my head. Because we will run into problems in here that are either going to be decimal answers or are going to be a larger number that you can't just do in your head. I need you to know the process so you can do it when we get there. It's awesome that you can do it in your head. Now we just got to get it onto paper. It's like your brain is the computer. This is the printout. We got to do the printout. We got to get the printer. So, let's play with another. Becky makes $30 a night for babysitting. Now, this one's a little trickier because when I see a night, okay, A doesn't, we see A a lot in problems. But in this case, that A is like saying, hey, $30 per night that we're looking. So sometimes A is going to be in here too. So Becky gets $30 per night for babysitting. Now, how did I know X is there besides that A? If I read all the way through, write an inequality to represent how many nights. $30 a night. Those go together. That's my X. That's my variable. How many nights does she have to babysit to make? Oh, at least, I need another color. There we go. At least $180. Not equals. At least. I want $180 or I want more. I want greater than $180. But $180 at a minimum. If I get more, that's okay. And again, this is on the front page of your packet too. But if you ever want like a note card like I'm doing just to have a separate piece there, that's okay. But we want to make sure we've got that, the note packet, every tool we're using to get there. So at least $180. And I'm going to put that symbol in there too so I can remember it later. It's all about the study tools. Nice thing about this one. One step and we're done. What's my one step? How do I undo that 30? Divide, because we're multiplying. Show the work, see the work, it will click more. So Becky needs to work at least 6 nights to have as much money as she wants. She can work more, but that's the very least. Again, I know some parts of this get complex, but again, the more we write it and say it and think it and do it, it will get better as we're going along. Okay. Now let's see if we can start making connections when we get to this third one. Diana went to rec night. Cool. It cost $4 to get in. Okay. It's $4 to get in. Let's just put the 4 for now. And concessions were $2 each for a drink and candy. She had $20. Okay, let's read the rest. At most, how many items she buys? So let's keep reading. It cost $4 to get in and concessions were $2 each for a drink or candy. Those would be items. $2 each. So that's the part that needs to get X. Some number is going to get X in every problem. So $2 each for a drink or candy. She had 20. At most, oh, one more thing to add. I swear I'm going to quit adding after this. At most, I don't want to spend any more than the $20 that I have. So that's going to be less than or equal to. I don't mind if I spend 20. I don't mind if I spend 19. I'm not spending 21 though. So if we can get to a point today that you can start to get the equation down, but we flip an arrow, that's okay. Or we flip x's around somewhere, that's okay. But I want us to get to something close to this, because again, now I have an example right above me that tells me what to do. I have a positive 4. Here I had a positive 52. I minused it. Okay. Let's do it. This is why we show steps. Minus that both sides. I'm just going to rewrite it here because I kind of wrote too big and I ran out of room. What did I do here? I multiplied, I divided both sides. Well, Hardy, it's an inequality arrow. Doesn't matter. We do the same process. So Diana could buy up to 8 items. I hope she doesn't buy 8 items. That's going to be a sugar rush. She's not going to be able to go to sleep. But I'm not worried about that. I just want the number. And so I put that down. Again, I've got to get in there and get the pieces, but I got to use this as my guide until I'm comfortable. It's like having an instruction manual when you're building something. Once you get good at it, you don't need the instructions. Until then, probably do. That'd be me too. Okay, last example, and then there's a couple of the problems on the sheet I want to do with you because they're a little kooky. Azim has paid off 3/4 of his car. He's paid $9,750 to the bank. Okay, here we go. Write an equation to represent how much the car cost originally. Now let's see where the numbers go. Azim has paid off 3/4 of his car. 3/4 of the cost of his car. Oh yeah, car. See why I want to figure out what x is first. It's going to help me figure out where the x goes. He's paid $9,750 to the bank. So 3/4 of his car is $9,750. He's paid 75%. He's almost paid it off. This is good. But now I've got this equation, again, that goes along with what we were talking about yesterday. So the question becomes, okay, probably a two-stepper. That's probably the route we're going to go. So I look and I go, okay, fraction is division. We undo divide by multiplying. Again, on this side, don't multiply the 4 times the 3. That 4's only job in life is to cancel that fraction out. 3x. I am not going to try and do that in my head on a Friday morning. 97.50. Oh, right there. 39,000. I already have it in here. 39,000. And one last step, I have a couple examples above me on what to do. And I'll have these on the quiz next week. If I learn to use them on my homework, when I use them on the quiz, it's simple, it's easy, it's straightforward. So, don't put these away because we're done. Okay, this isn't like a book and I'm done reading it for now. We're just getting started with this. So, keep this handy. We are going to jump over to the practice part. On 15 and 16, but our notes are right there, still on the desktop, helping us out with some things. 15.
15. All right.
Yep, 1.4 day 3 if you hadn't happened to number. And again, if you need practice or notes, let me know. I will get you some new ones because I got some more done yesterday. Okay, so I want to do, I'm trying to think here for a minute. Just 1 second. All right, we're going to do 4 and 8, and then we're going to come back from there because I'm just trying to look for ones that I think could cause us a problem. Ooh. Let's actually start with 3. So some of you, again, not even thinking about an equation at the start and how your brain can get the equation for you. If I read 3, John went to the Boone County Fair and spent $12. He has $40 left. How much did he start with? Okay, how much did he start with is X. Bless you. So I started with some amount of money. Might have been $50, $80, $100, I don't know. He started with X. I went to the fair and I spent 12. What does that mean? Like in math terms, I spent 12. Minus. I spent 12. Minus 12. He has $40 left. So if I had my money at the start and I spent 12, now I have 40. Just like that, you have an equation. I bet a lot of you could have looked at that and said, well, wait a minute. If I have 40 left and I spent 12, and you probably sit there in your head and be able to tell me it's 52. Just with common sense and logic. So now the idea is just, I need to get that into mathematical equation mode. I know what the answer is. And so I just keep working at the equation until I get it. Or I use the answer key and I work backwards until I get it. So everything's not going to be the exact same every time, but sometimes we can just use a little common sense. So, number 4. Sue wants to sell Harlem shirts for $15 each. How many shirts must she sell to make at least $100? Again, we got shirts that are $15. We know each means a variable. How many shirts? I'm getting $15 for each shirt. That goes together. So I get $15 for every shirt. I want at least, I'll even put it on here, $100. Every piece adds a little bit to our expression. So you're like, okay, so even if I'm looking back at one of the problems up here, I'm like, well, every time I do this, I end up having to divide. So I'm going to divide. And here's going to come our first dilemma. So 100 divided, 100 divided by 15 is 6.66666. Now, here's a problem. Can I purchase 2/3 of a shirt? I don't know what that would look like. Maybe they'd cut off one of the arms or something like that. Maybe. I can't sell 0.6666 of a shirt. So here's the question. Do I have to sell at least 6 shirts, or do I have to sell at least 7? I agree. I have to sell at least 7. Now, does that mean every time there's a decimal I have to upgrade? No, but here, if I'd have only sold 6 shirts, I'd only get $90. I need at least 100. If I sell 7, I'm over 100. So if you're not sure, we can test it out to check. But mainly on those, if in doubt, round up. Okay. Again, we've got the forms. Okay. One last one. You're like, oh, Hardy, come on now. It's Friday. I know. But I want to make sure we're okay. Okay. Number 8. Then you're done with dealing with me directly talking. May not be forever. Number 8. A recent survey of 13 to 15-year-old girls was conducted. Of those surveyed, 225, or about 9/20ths, once we're done here, said they talk on the telephone while they watch television. About how many girls were surveyed? Okay, let's start putting this to this. Of those surveyed, about 9/20ths of the girls surveyed is going to be 225. Now, you may look at that and say, wait a minute. Wouldn't you just do 9/20ths times 225? And the answer is no. They're telling me what part of all my people the 225 is. Okay? So that one's a little tricky in the way that it's worded. Number 7 is going to be a little easier because it's similar. But here again, we've got an example if we're not sure how to tackle it. You have an example. Use it. Oh, it looks like I multiplied by this number. Okay, let's see. So multiply by 12. Ooh, I did it to both sides. We're faking it till we make it, people. I can't do 225 times 20 in my head right now. 4,500. Bless you. Looks like a little division working. Oh, it's not $500. My goodness, it's 500 girls. I'm not talking about money here. What are we doing? So, both sides of this page, set them up, work on them. You have an answer key up front. It is okay to get up and look at the answer key. You're not going to get in trouble. Or you can even look at it on Classroom. That's fine. It's not cheating if you've tried something and you're trying to work through it. But you've got to keep working through it. Because you're not going to have me at your side when it's time to do the quiz next week. So again, if over the weekend you end